Instead it will go up straight in the air to a distance y is equal to u square by 2g, and then it will come down. This is the angle of projection theta, which is 90 degree. So let's get familiar with some useful properties of projectile motion. The first property is, for complementary angle of projection, range of projectile remains same if the velocity of projection remains same in both the cases. So we can prove this property mathematically. Suppose there are two projectiles, both are being thrown at same initial velocity u, and the angle of projection for the first projectile is theta 1, which is equal to theta, and for second projectile it is theta 2, which is complementary of first angle, that is, it is 90 minus theta. So as we have seen, the expression for range is r is equal to u square sine theta by g. So in the first case, the range r1 would be u square sine 2 theta by g, and in the second case, range r2 would be u square sine 2 theta 2, and the value of theta 2 is 90 minus theta by g, which is equal to u square sine 180 minus 2 theta by g, which is again equal to u square sine 2 theta by g. So here we can see that r1 is equal to r2. Now let's move on to another property. What is the angle of projection for which the height of projectile is same as its range? So to find this particular angle of projection, we'll do the following thing. So we need to find out the angle for which the range of projectile is equal to its maximum height. So we know that the range of projectile is given as u square sine 2 theta by g, and the maximum height is given as u square sine square theta by 2z. So if we expand the expression in left hand side, we'll get u square sine 2 theta by g is equal to u square sine square theta by 2g. Sine 2 theta is equal to 2 sine theta cos theta by g is equal to, we can cancel out u square here and we can cancel out g, so this will be equal to sine square theta by 2. This thing is cancelled out, so from here we can get 4 is equal to sine theta by cos theta. Cancel out this sine theta, or tan theta is equal to 4, or theta is equal to tan inverse 4. So when a projectile is projected with this particular angle of projection, that is tan inverse 4, its height, its maximum height attained will be same as its range. Another property of projectile motion is that the sum of the two roots of the equation of trajectory gives the range of the projectile. So let's see this. We know that the equation of trajectory of a projectile motion, that is equation of its path, is given as y is equal to x tan theta minus g by 2u square sec square theta into x square. So as we can see that this equation is quadratic in x, so the sum of the roots will be given as minus coefficient of x by coefficient of x square. So we have coefficient of x as tan theta, so minus tan theta, and coefficient of x square is minus g sec square theta by 2u square. By 2u square. So this minus sign will cancel out, and we can write tan theta as sin theta by cos theta, and sec square theta is as 1 by cos square theta into 2u square. So cos theta will cancel out, so we get u square into 2 sin theta cos theta by g, or this thing will equal to sin 2 theta. So we finally get sum of the roots, which is u square sin 2 theta by g. Now this is same as the expression for r. So the equation of trajectory, which is a quadratic equation, sum of its roots gives the range of the projectile.